Hello. Hi, good evening, everyone.
Good evening.
Good evening.
Hello.
Good evening, ma'am.
Good evening. So in the last session, we have discussed on AHB protocol, right? We have completed the specification now. So today we will discuss on AHB protocol UVM verification. Okay. Do you have any doubts in before session on AHB? And also next week we'll have one session weekdays, one session for AHB2 APB bridge. Okay, so that we will complete the bridge. And Saturday we will start with the AXI protocol. Okay, AXI will cover in 3 to 4 days more detailedly. We will discuss as per the schedule. I think 2 or 3 days. Okay, so. Okay, today we need to discuss on UVM. Whoever don't know UVM, just skip as of now. Whoever know, just concentrate. First, we will revise all the topics of UVM. Just quick revision. So, what is the difference between System Verilog and UVM in terms of architecture?
So, System Verilog is a language to write the test bench. Is a class-based language, and it is dynamic in nature. But UVM is based on UVM is not a language. UVM is based on System Verilog. It is actually a methodology. It is a framework, which actually it is a which becomes a standard for all the industry. I mean, wherever you go, you have some fixed format that we need to follow.
Okay. In terms of architecture,
Ma'am, system Verilog has
It
generator,
gives the classes of like UVM driver, UVM,
generator driver, and a monitor.
okay. In
And in
UVM,
UVM have sequencer, agent. In an agent there is a monitor, driver, scoreboard, sequencer,
okay. What is the difference
and
between sequence,
and
sequence, system, and
TLM
sequencer?
ports is there in UVM.
Okay.
Ma'am,
What
sequence is a
mm,
object, and while sequencer is component.
okay. Sequence is a object, sequencer is a component. What are the objects and what are the classes components in UVM?
transaction is a object transition sequence, and other than that, all generator, sequencer, monitor, driver, scoreboard, though these are components.
Okay. Okay. Any other best features in UVM?
So,
In
so
UVM,
it
ma'am, there is
provides.
a already written library which are going to extend and use the properties.
Okay. So, what is the difference between mailbox and TLM port? What is the difference between mailbox and TLM port?
Mailbox is like first in, first out FIFO.
Okay.
And TLM port gives us more features.
What features? What is the difference between active agent and passive agent?
Ma'am, active agent consists of sequencer, driver, and monitor, and passive agent consists of only monitor.
Okay. So what is the use of active agent and passive agent?
Ma'am, active agent used where we have to drive and monitoring some signal, and passive agent used only where we have to only monitor.
We have to collect coverage there. There we use passive.
Collect the drives data.
Okay, fine. So, in system Verilog, we have callback methods, right? What are the callback methods we have in system Verilog? And what are the callback methods in UVM? What are the callback methods in system Verilog and what are the callback methods in UVM?
Ma'am, in UVM, we have some extra features like we can pre-randomize and post-randomize. We have some additional features in callback.
Those are in system Verilog, right?
Okay.
Okay, pre-randomize and post-randomize or callback methods. Okay, what is the use of pre-randomize and post-randomize?
Pre-randomize to set the variable and post-randomize to, I think, display.
Mining, are you there? Do you know UVM concepts? Srija, Nitin, Sweta, Vinita, Ashwini,
No, ma'am.
remaining?
Yes,
No, ma'am.
aware.
Callbacks, I'm not sure. Or UVM.
So many times we discussed callback methods. In system Verilog, we have pre-randomization, post-randomization. In UVM, we have pre-body, post-body, and main body. So what is the use of that?
Ma'am, please repeat again.
Pre-body, body, post-body.
In
Where we use
system
body
Verilog.
method. In system Verilog, pre-randomization and post-randomization. What is the use of pre and post there?
To set the variables, to set the values in the pre-randomization, and in the post-randomization to display, I mean, after the randomization to display the results, or if or randomization failed, whatever, I mean, pass or fail in the post-randomization.
Okay. If any information statements are there, if we want to print the information statements, we use pre-randomization and post-randomization without changing actual randomization. Okay. We should not change actual randomization functionality without changing that extra statements, just extra statements we are writing. That's what we call as a callback methods. Okay. Next, what is meant by factory registration in UPM? How can we register a component or a object or a variable?
UVM component utils and UVM object utils.
Yes.
Okay.
It will manufacture the object and component.
Okay. So why we use the factory first of all? What is mean by factory?
Ma'am, it will manufacture the component and object.
Okay. You just create the objects dynamically. And
Yes.
also we can override the data easily. So that's why we use the factory registration. Before we have used lot of methods like by taking the wrap ID and we need to mention the ID. There will be like 5 to 6 steps will be there. But without taking all those things, just we can use the macro, that is UVM object utils for creation of object, UVM component utils for creating the component. Okay, fine. Next, in UVM, phases also most important. So what is meant by phases and what are the different types of phases are there in UVM?
Phases is like from where like from starting to end, how the program goes on. So it is actually distributed in several phases, several parts, like build phase, connect phase, start of elaboration, runtime phase, and elaboration, check phase, report phase,
Report
final
phase, final
extract
phase.
phase, and final phase. Yeah.
Run
So basically,
phase,
so
pre-reset
basic,
phase.
Okay, so
bas- basically,
what is the use of
basically,
phases?
phases helps
So
in
that all components
synchronization
actually
of
run
all the
parallelly. It gives a synchronization. I mean, all should work parallelly, and
It
it will.
controls the simulation across all the components.
It controls the simulation across all the components. Okay, okay, fine. Any more examples like uses? Any other uses? Okay. In UVM, we have a RAL model, right? Can you explain what is the use of RAL model in UVM? What is the use of RAL model? What is meant by RAL? Register abstraction layer. So what are the different blocks available in register abstraction layer and what is the use of that?
It has adapter, predictor, uh, and mm, s- I mean, yeah, it has yeah, adapter and predictor. Uh, so uh, I mean, so it converts the actually reg values to bus values, and whenever I mean reg to bus values, via it goes to the uh, to the to take the signals from the DUT, and from DUT to reg RAL model, it converts from reg bus to reg models via using adapter.
Mhm. What is meant by predictor?
uh, Predictor is it predicts the it predicts uh, the bus values which are coming from the monitor, uh, and match with the whatever the reg value, whatever the values are present in the RAL model. Based on that, not sure. I mean, forgot actually. I'll need to see.
We already discussed all UVM concepts, right? You already there.
Yeah, I already there. I'm just forget that. Yeah, I'll see that.
What is
Ma'am,
meant
in
by
a,
door access and backdoor access? Yeah, tell Karthik.
ma'am,
Yeah, go on.
ma'am, please repeat.
What are you asking?
Ma'am, Faces are designed like bottom to top, top to bottom, and some parallel, no? All are not working.
Hmm. Okay. Why top to bottom and up to down?
Yes, ma'am, that's a question.
Top.
I don't understand.
Okay. So which faces will work top to down and which faces will work down to up?
Ma'am, build up phase and final phase work top to down, and other phases except run phase work bottom to up, and run phase work parallel.
Okay. Why run phase is working parallelly here?
Ma'am, because run phase may contain some delay, and run phase is not a function, it is a task.
Okay. So actually build phase, connect phase, end of elaboration, start of simulation will be top to down. Top to down means first of all those will execute test top level and then test first test bench.sv, then test, and then environment, and then internal connections, sequencer, driver, monitor, scoreboard,
Okay,
and
ma'am.
connection top to down. So how we are connecting? Connecting wise, we need to come from a lower level only. But as we see all anywhere books and all, it will show top to down only. But connection wise, we will make from internally, right? From first of all, we do a sequencer to sequence via sequence items will be connected and sequence to the driver, like that only we will come from down to up. But pronunciation wise, like it will be like top to down. Remaining extract phase, check phase, report phase, final phase, all are bottom to up. That means lower level to higher. Okay. So because we need to extract the data from lower level blocks, like from sequencer, driver, monitor, one by one, in same as check phase, report phase, final phase also. Whereas the run phase, it's not a function. Remaining all are functions, but run phase is a task where we can do it start from zero simulation time, and we can do actual task. Whatever the functionality is there, we can put in the run phase, and according to the delay, it will be working. Okay. Remaining functions, we don't put any delay, but in task, we can add the delays. Okay. So that is what from parent to child to parent. Build phase, connect to end of elaboration, start of simulation. These will be top to down. That means up to down, parent to child. From UVM test to lower level components like agents, drivers, scoreboard, like this. And remaining all are bottom to up, child to parent.
Ma'am,
It
first,
allow the,
ma'am, first four will work top to down.
yes. Last four will bottom to up, and the middle one run phase will be concurrent. Total 9 phases.
I think can you check? I think ma'am, build phase and final phase will work only top to down, and run phase will work parallel, and the rest ma'am work bottom to up, like connect phase, end of elaboration, start of simulation, extract phase, check phase, report phase.
No,
Can
first
you
four
ma'am
will work.
check and confirm me?
First four will work top to down.
Yes,
Okay, ma'am.
it will work top to down first, right? Because all are part of connecting a TV hierarchy, right? So if you want to create an hierarchy, so we always need to have a parent object first. So that's why this build, connect, and end of elaboration, whatever ma'am is saying, will be top, top to down. Yes.
Ma'am, please check and confirm.
build phase and final phase of top to down.
And rest will work bottom to up.
So here the build phase consists of the build phase, connect phase, and end of elaboration phase. If you again break it down, so it is connecting that, and the final phase will be different. So if you go deep inside that build phase, so it will again consider this build phase, connect phase, end of elaboration, something like that. I don't know why this is there.
Build phase, final phase, top to down, connect phase, end of elaboration, start of simulation, extract, bottom to up.
And
And
rest run phase is parallel.
Okay. Connective phase only I have doubt before also I told right before
Yes, ma'am.
from down to top only we will connect, but how it will I have doubt that
Yes,
connect
ma'am.
phase. But end of elaboration, start of simulation, all also coming bottom to up. Okay. Okay, I will again recheck and will confirm.
Okay, ma'am. Thank you.
So next, RAL model. Why do we use the RAL model?
To
RAL
mirror
model
the
we will discuss one day. Okay, maybe if you learn UPM by your own, you may not focus because it's the last topic of UVM, right? So I will clearly explain why register abstraction layer is important, how the data is converting into the register type, and register data is converting into the binary data, which is acceptable by driver, and what is the difference between predictor, adapter, and backdoor access, front door access, and what are the different types of methods are there, like reg to bus and bus to reg. All these things after AXI or before AXI, one day we will discuss. Okay, or else I will share you the recorded session. As of now, today we will start with AHB protocol verification. So already
Ma'am, I
designed
have doubt.
specification. Yeah.
Ma'am, what is the difference between ma'am TLM and that
Mailbox.
mailbox? Yes.
See, mailbox doesn't have the rules. One thing is through the mailbox, you are sending the data from generator to driver only. Right? Generator will work as a transmitter, driver will work as a receiver. Put and get methods only will work. But coming to the TLM port, it's not a simple concept. It's a rules, protocol rules we need to follow. It's like a protocol. Okay, where it have the producer and consumer. One can be initiator, one can be the target, and both are interchange. Initiator can be a target, and target can be a initiator. Okay, so sequencer side it can be the initiator or target. Driver side it can be a initiator or target. Both are interchangeable. That means what we have the put method and get methods in the mailbox, right? Based on the put method and get method, we will differentiate. Okay, so by not bidirectional, both are interchangeable. Anyone can generate the data and pass, but in mailbox it is not possible, right? So that is the main difference between mailbox and TLM port and the advantage of TLM port.
Ma'am, TLM port have some like FIFO or what? I have not clarity in that.
Okay, TLM port have with the FIFO concept and without FIFO concept also. Without FIFO means what? Target to initiator only. Suppose if you are sending target to target or target to target, initiator to initiator, then in the middle we need to use the FIFO. Did you got my
Okay,
point?
ma'am. Yes, ma'am.
The FIFO in FIFO concept, it will work like a suppose initiator. Normally we will send the data from initiator to target or target to initiator, opposite. But if you are sending the data from initiator to initiator or target to target, we can't send directly. So in the middle, we use the TLM FIFO. So if it is a target and here also target, then here it will work as initiator and here it will work as a initiator. So for that purpose, we use a TLM FIFO.
Okay.
I will share you the material. Just look at that. Okay. Next, coming to the AHP protocol, just a quick revision. Can you tell what is the difference between burst, transfer, and increment to wrap? Increment 4, wrap 4, increment 8, wrap 8, increment 16, wrap 16. Fast. And what are the different types of transfers we have? Did you forgot?
Yes, ma'am.
Yes? Did you forgot the concepts?
What concept?
Yes, ma'am.
Hello?
AHP protocol.
No. Yeah, we have like non-sequence, sequence, then busy.
Fine. Okay, see here. First of all, design program, RTL design for AHP. So it's interface block, and within interface, we have written module also, both interface and module in a same design block. So first of all, package, we need to include the package and type def using the enum. We have n number of states, right? Ideal, active state, write burst, read burst, again, little, and operation. Okay. And then we need to define the different sequences. First, non-sequence, sequence, busy, ideal, okay response, error response, split, retry. We have these types of split, retry as of now commented. And package. And coming to just UVM macros, this is just including .svh file, because in every UVM file, we need to include the package and also macros. So UVM macros and interface block. Interface block is nothing but from driver to DUT, we connect via virtual interface and interface, right? So that's how we return the interface block here. Interface AHB if logic, we need to declare all input and output variables with the logic. You already know what are the AXI signals, H select, write, clock, actual, reset. And this is just temporary clock and reset, not main clock. This clock we will generate first and will assign to the H clock. Next, H address, H write data, read data, size, burst, trans, H master lock. We already discussed all these concepts individually. H ready, just for waiting purpose, and state H response, local address, just address and count value to count the clock cycles. And within interface, clocking block, master master CB in the sense related to the driver clocking block. For monitor, didn't return the clocking block, so it's related to the master CB and modport master and interface. Okay. Next, import AHB package. We need to import within the design. And coming to the module, main RTL design. RTL design of AHP protocol. here AHB IF SINTF is nothing but whatever interface is there here. AHB IF is the interface name. Okay, and here sign interf um, just a instance of that interface, so that what happens, we no need to declare all the variables again in the design module. Okay, like this also we can write. And declaring memory, some memory. And for final state mission, you already know we need to write the present state and next state. So here we are writing the present state and next state. So range 30 down to 0 address buffer bit opcode. And next, always ff posage dot sign tf dot clock. Whatever we have, the clock is written in the interface block. So how we are accessing this interface clock? Through the instance of interface. AHB IF is the name of the interface. Sign TF is the instance of that interface. So we need to access through the instance, nothing but object. So sign TF clock or negate asynchronous reset. Okay. So if reset is 0, active low, present state is equal to ideal, next state, present state is equal to next state. Okay. Next, initial begin, memory slave, just creating some memory, new 8192, just any value you can assign. And next, always at the rate of clock or negate reset, begin. If reset is active low, then next state will go to the operation, main operation. For each memory of slave of I, memory slave of I is equal to I, just assigning the I value. Okay. What is the I value here? What is the I value? Nothing but address. Okay, slave address value. So case based on the present state slave value. If present state is ideal, begin. If reset is high or if reset is 0 and H select is equal to 0. H select equal to 0 means what? We are not selecting any of the slave. Okay. If any of the slave is not selected, then can we pass any address? If you pass any address to which slave, it will be passed. So we can't work. So it will be ideal state. Okay. Else begin. If ready is high, that means wait state. Wait state means what? Still ideal state, or whatever the present state we are in, we need to wait there only. And local address is equal to 0 initially. Next state is equal to operation state. Next state. First state is the ideal state. Next state is the operation state. Okay. So here, if H trans is equal to 1, 0, H trans is equal to 1, 1. What is meant by 1, 0 and 1, 1? H trans is equal to 1, 0. H trans is equal to 1, 1.
So it's a non-sequence. 1 0 is non-sequence, and 1 1 is the sequence. So non-sequence basically means the first transfer of a beat of a burst, and the sequence would be the remaining transfer if it's not busy.
Okay. Just a second. So H trans 10 means non-sequence, 11 means sequence. Ideal means ideal and busy.
Yeah, so the ideal means that bus is free and master is not initiating any transfer, and busy will be like a transfer is about to occur, but it's not ready yet. The slave is not ready yet.
Okay.
Sorry, the master is not ready yet because it's from master to slave. So, yes.
Am I audible?
Yes.
Okay, see, ideal means 0, 0, busy means 0, 1, non-sequence means 1, 0, sequence means 1, 1. Okay, so here non-sequence means 1, 0, sequence means 1, 1. Okay, so whenever H trans is equal to 1, 0 or H trans equal to 1, 1, then opcode equal to 1, H write is equal to 0, so write operation, and H address buffer is equal to H address. Okay, this H address is the main variable where we generate the address that is assigned to the address buffer. Okay, in that case, H read is read data is equal to write data. Write data is assigning to the read
What
data.
is this opcode?
Opcode is just for memory related. It just indicate memory. Here, opcode is just enable signal like that.
Okay.
Ma'am, have we used it in
Hmm?
design?
What?
Have we used this signal in design?
Here, here we didn't use. Here opcode is just this address. It indicate the address values. Okay. So whenever opcode is high, write is equal to 0 and H address is equal to the address buffer. Then write data is assigning to the read data. Else write is equal to 0. Then memory slave of H address. That means memory of H address is assigned to the read data. Okay. So else H or data is equal to 0 in else condition. Reset case in else condition. And H address buffer is assigned with the H address. Opcode is nothing but H write. Okay, H write.
Prashanti, the screen is not visible.
Screen is not visible.
No, it's visible.
Okay.
Is it not visible? Operation is
Yes.
assigned to the slave. And if opcode is equal to 1, this H write data is getting assigned to the memory of address. H write data if opcode is equal to high. Opcode means what? H write. H write 0 or 1. Right? Both write
But
and
what
read
is the
sequence
need?
will
What is the
indicate.
need to define this opcode signal?
Just it's a temporary variable here.
But we are
Opcode is
checking
just
in one condition, right? Like although we are assigning that H right to the opcode, but in before line in the if condition, we are checking for opcode to be 1 along with H right to be 0, right? So
H write is equal to 0. Okay.
yeah, so why we are using that opcode over here? What is the significance of it? Like how that would be
Here
helpful to
opcode in
us?
the sense first of all it will indicate the memory address. Okay, in this case, we are just assigning the H write value to the opcode. So whenever opcode here opcode is equal to high and H write is equal to 0. Okay, H write equal to 0 means it indicates the write operation, equal to 1 means it indicates the read operation. In the same way, here we are just assigning the opcode just related to the address of that particular memory. Okay, so this equation is different and here it is different. So here we have written in a if condition, if it is 1 0 and 1 1, if trans is 1 0 and 1 1, then only this if condition will work, or else it will go to the else if. Okay, if that also failed, then it will come to the else state. In else state, we are assigning the H address to the address buffer and H write to the opcode. That means here opcode and H write are not same. In this case, both are not same. But in else condition, we are assigning some value we need to assign it by default. So that's why H write assigning to the opcode. But here in this case, opcode is just representing the address. Opcode like enable signal.
Ma'am, H
Okay.
write 0 means read operation.
H write where? H write is equal to 0 operation. Maybe it totally depends on design engineer also. Suppose if you want to put H write is equal to 1 as a write operation, that's our chance. If you want to put H write is equal to 0 as a read operation, that's our chance. Up to you. But here H write for write operation, H write is high and read is 0. So here H write when declaration of signal, it will indicate whether it is write operation or read operation.
In design.
Here actually H write is equal to 0. Okay, fine. Write data is assigning to the read data. Write data is assigning to read data. It means what? It's read operation, right? Write data is assigning to read data. That means for output we are getting the read
Yes, it's
data,
read operation.
read operation.
But
Okay.
this,
So that is what till here. And then if opcode is equal to 1, see here, memory of address buffer is getting assigned with the H write data. See, opcode is just as indicating as like a enable of that memory. Okay. So memory of address buffer is any location value to that H write data is assigning. Okay, in which case whenever this case is failed and this is if we separate. Okay, separate case. Else H response is equal to OK response. That means correct data is correct. Okay. Next, suppose in active state, present state is active state. If H reset is low and H select is high and H write also high and H ready is also high, then what will be the output? H ready is also high. Hmm? till it comes 0, we need to be in a wait state, right? So here H address is assigning to the address buffer, and write burst is equal to assigning to the next slave. Next slave means here it's a next state, present state and next state. Okay. Else if the set is 0, H select is high, H write is low. It's read operation. H ready is high. Then okay, H ready is high means no wait state. If H ready is low means then it's a wait state. Okay. So here H ready is high, so no wait state. So address is directly assigning to the address buffer and read burst. Next state will be the read burst state. Okay. And then or else next state will be the ideal state. Here two cases we have written. In active state, we are just telling what is the next state. Okay. In this condition, write is high. So write next state will be the write burst. And here in this condition, write is low. So next state indicating with the read burst. Okay. Or else next state will be the ideal state. Okay. Next again state repeated. If H ready is high, it will go to the active state because it's not busy. We can access the data. The slave or master can read or write the data. Here next slave, suppose H ready is 0, it indicating as a little state. We can mention it like little or wait state. We can mention as a wait also. Okay, so here it just indicating as a little state. If H ready is low, okay, we need to wait until it gets high. So here if you see up, right burst will be the next state if the condition is satisfied. So what we have written in the right burst, if H reset is low, H select is high, H write is high, write operation, right? How we write the data, that's the main thing. It depends on burst, type of burst. We have two types of burst. One is increment, one is wrap. In increment, 4-bit, 8-bit, 16-bit. In wrap, 4-bit, 8-bit, 16-bit. And also normal one, like normal transfer also we have. Okay. So the transfer is depending on write burst. In write burst stage, transfer is depending on H burst. Okay. If H burst is 000, then what is the operation here? Single transfer, 000. 001, incrementing transfer, incrementing burst transfer, 001. 010, 4-bit wrap transfer, wrapping. 011, 4-bit incrementing burst transfer. 100, 8-bit wrap transfer. 101, 8-bit incrementing transfer. 110, 16-bit wrapping burst. 111, 16-bit incrementing burst. Okay, like that we have these many operations. We need to understand everything line to line. Okay, so 000 means single transfer. Okay, so here just H burst is high. In the write burst state, we just need to write the data. To where we need to write the data? To the memory of location. That's what write operation. Read operation means from the memory of that particular location, we get the data out, retrieve the data. That's what read operation, right? So here write operation means H write data assigning to the memory of address. Okay. Address buffer, whatever this address buffer is there, sign in whatever the instance of interface.h address assigning to the address buffer. Okay. Next, if it is okay, the data is correct, okay response, we get the okay response. And if H write is equal to 0, 1 non-sequence, then next state will be the write burst, or next state will be the read burst. Okay. Next 0, 0, 1, same 0, 0, 1, 0, 1, 0, all are same, but how we are incrementing the data need to check. Okay. Normally, what will be incremented? Nothing but H address will be incremented, right? So if you observe the PPT here, comparatively here 4-bit wrapping means 8C, 38, 3C, 3034, 4-bit increment. In the same way, incrementing 38, 3C, 4044, 4-bit. And 8-bit means 34, 38, 3C, 20, 24, 28, 2C, like that. Total 8 number of bits will be incremented. Okay, in the same transaction. Okay, like that. Here 001 means incrementing burst unspecified. That means +1 it is incrementing. So H write data is assigning to the memory of address. H address is incrementing +1. Okay. In the same way, counter also should increment +1. If count value is less than 32, next state will be the write burst state only. Okay. 32-bit data. Till then it will be in write burst only. Else, H ready is equal to high. H response is equal to OK response. Next state will be the ideal state. Okay. Why? Because 32-bit data is completed. Till 32-bit, it will be in the write burst. That means it will write the data. Once 32 is completed means what? Above 32, data transferred, every data transferred. So H ready will be high. We'll get the OK response and it will go to the ideal state. So next state will be the ideal state. Okay. Next, 4-bit wrapping burst. 4-bit wrapping means what? Write data is assigning to the memory of H address, and H address plus 4. Okay. H address plus 4. Count is equal to count plus 1. Number of count cycles it will count. 4-bit rast means what? Count should be 4. Total 4 bits will be divided, right? 4 transfers. So count is equal to 4. Okay. And remaining just check same. Next 4-bit incrementing burst. So same here. H address is equal to +4 and count is equal to +1, and count should be less than 4. 0 to 3. Total 4. 8-bit means what? It also same, +4. It should increment, but count value should be equal to 8. Total 8 number of transfers. Okay. So count value is 8. And next, here same, 8-bit incrementing burst. Count value should be less than 8. And here count 16-bit wrap. 16-bit wrap means again H address is equal to +4. But count value should be 16 because whole transaction is divided into the 16 bits. Okay. So that's why count is equal to 16. Next, count is equal to less than 16 here. And same, remaining all same. And read burst. Write operation is completed based on all the conditions. Wrap, increment, 16, 8, 4. Okay. Now read burst. Read side also same only, right? Reset is low, H select is high, write should be low for read operation. And if case H burst, based on H burst, 0, 0, 0 means a normal single transfer, 0, 0, 1 means increment transfer. Counter value is less than 32 for read side. And 0, 1, 0, 4-bit wrapper, 4-bit incrementer, 8-bit wrapper, 8-bit incrementer. Just observe. Read operation means what we are doing here. Memory of address, memory slave of H address is assigning to the H or data, read data. Okay, write operation means to the memory of location, assign the write data. Okay, but here reverse. So for 8-bit incrementing here, 16-bit incrementing and 16-bit here also same. All are similar for all different methods. Next, a little state means wait state. I already told, right? Wait state. So H master lock. If H master lock is high means what? Particular transfer is locked only to that particular master, and remaining all should be inactive. So next state will go to the active, else next state will be the ideal state. Okay, so this is how we write the AHB design program for all burst transfers. Just take time, line to line, you need to understand, then only you can able to understand properly.
Prasanti, down, what is the little like it's something is defined like yeah, this one.
Little is nothing but, if you see here, we written the condition before I explained little
Yeah.
condition.
Like operation little
P ready
we
is
have written.
low. If P ready is low, it is going to the little state. That means what? It is not ready to accept the data. We need to wait until P ready is high. So it goes to the little state. See here again, if H ready is high, it will go to the active state, so that our entire operation will be same, or else it will go to the little state. So P ready is not high. Okay, so in little state, just if master lock is high, it will go to the active state, or else it will be in ideal state.
Okay.
If it is P ready is low means what? The receiver is in busy state. So it is checking with the master whether master is locked, or it can move to the some other master, because P slave is busy, right? So if master lock is not high, it will go to the ideal state and will assign to the another master. So that's what here it is checking with master lock signal.
Okay.
Okay.
Hi
Others,
Prashanti.
yeah.
Hi Prashanti. This code is like for multiple master, multiple slaves. This code is for
Multiple masters means here we didn't written multiple masters, single master only,
okay.
but just master lock signal used.
Slaves. Okay.
Here it is a slave design actually. Entire design part is a slave. Master is a test bench,
Okay.
UVM test bench.
Okay.
Okay. So design wise, everyone clear? All bus transfers.
But slave we have two, right? One, two, like because it
Slave
was
X we have written.
sorry.
Slave X.
Okay.
So that slave X, if you want to write physical slaves, slave X means you can take the 3 slaves, and in the main top level, you can connect the port list, slave 1, slave 2, slave 3. Like that, you can take the copies, just copies only, right? That slave 1, 2, 3, those values we will take in the test bench. So slave 1 means any address value you can mention. Slave 2 means some address value. Slave 3 means some address value. Based on that particular design will be selected, and according to that we'll get the output. Did you got my point?
Okay.
Same as the structural modeling. Suppose we design the slave X now. This is main design code. So slave X code we have designed. By using this slave X code, I'm telling you to take the copies. How we take the copy in the top level test bench. slave X, 3 copies, slave 1, slave 2, slave 3. Okay. So this slave 1, slave 2, slave 3, we need to take in the test bench. Slave 1 is equal to particular value, slave 2 equal to some value, slave 3 equal to some value. Okay, so according to that, which design, suppose you have given slave 1 is equal to 0010. So this design will be selected, that master will send the data to that particular slave. Like that, if you have selected slave 2 is equal to some value, so that master, you need to interconnect, right? So that master will send to the value to the slave 2, like that. Okay. Any other doubts? Okay. So coming to the UVM, how can we verify? Interface already written, right? So after interface, what we need to follow? The flow sequence item, nothing but transaction class. So where is the sequence item? Okay, directly transaction is there here. Okay. Okay, see here. AHB class AHB transaction extending from UVM sequence item, declaring all the variables, input variables with a rand type, rand and outputs no need to declare with a rand. And transaction is an object, right? So that's why we need to write the tick UVM object utils AHB transaction. And all these variables we call as a field. So that's why UVM field int, whether it's a bit data type or byte data type, integer, all this comes under int, field int. If it is a array, then array int. Okay. Like that, we need to declare all this. I think no need to explain everything line by line. You already know the concepts. Next, object utils end. Okay. Next, need to write the constraints. H size is equal to 1, busy state equal to 0. This is one constraint. And there are a lot of constraints actually. Busy location size is equal to some busy state assign. And these location values of I. Busy location is nothing but busy location. For busy location assigned with the busy state. Okay, busy location CON, unique queue of busy location. Okay, H burst 00 means singular, 001 means incremental, 010 means wrap 4, increment 4, wrap 8, increment 8, wrap 16, increment 16. Like that, H size 000 means 8 bit, 001 means 16 bit, 010 means 32 bit. You already know in the specification already mentioned. Based on that, here generating the constraints. Okay. So these all are different types of test cases. In this HTTP protocol, there are a lot of tests. Just check. Constraint address length. If H burst is equal to 000, address length is equal to 1. 001 means what? Increment. Then address length is equal to 8. Observe carefully. Increment means length is equal to 8. 010 means 010. Wrap 4. So address length is equal to 4. 011. Increment 4. So address length is equal to 4. 100. Wrap 8. So address length equal to 8. 101. increment 8, so address length is equal to 8. 110 increment 4 or wrap 4, address length equal to 16. 111 address length is equal to 16, wrap 16. Okay, that wrap is just denoting with the length. Okay, in the same way, size. Constant h data size h address dot size is equal to h. Okay, okay, h length h address dot size must be same. Okay, and h data size should be equal to h address length. H trans size must be equal to address length. Okay, 0 0 0 single means 8-bit. 0 0 1 16-bit. Okay, size is different. H burst is different. Okay, H is just length is assigning to the size. Okay, so here these all the lengths and constant h data of I. For each data of I, what are the constants generating h data of I inside 0 down to 32? 0 to 32, 0 up to 32, sorry, 300. That's what the data value, data of I array. And h size is 2-bit only, right? So 0 to 2, 2-bit, 3-bit, 0 to 2. H trans, soft constant writing here. Okay, h trans of 0 inside 2. Okay, like that h right, either 0 or 1. H select equal to 1. See here, h select is equal to 1 because we have only one slave here. So that's why h select is directly indicated to 1 because of h size. Okay, not because of h size, because of one slave. Next, h trans of I, trans of I is equal to 3. If I is not equal to 0, h trans of I is equal to 3. Okay, h trans means, okay, non-sequence, sequence, ideal, busy. Okay, h trans is equal to 3 means h trans 2-bit size 0 0 0 1 1 0 1 1. Okay, if I is not equal to 0, then h trans of I is second bit, that is 3. Okay. Insertion of wait state is taken care in driver, not here. Okay. See, from second bit onwards, h trans should be always 3. Sequence we have, right? First non-sequence, then sequence. So to indicate that it should be 3 always. Okay. Next, h size. If h size is equal to 0 0 1, then h address. Okay. H address, how it is dividing. See here, already we have sizes. 0 0 means 8-bit, 0 0 1 means 16-bit, 0 1 0 means 32-bit, 0 1 1 means 64, 1 0 0 means 128. Based on that, we get the incremental wrap 16, 8 like that. So address we need to generate according to that, right? So 0 0 1 means H address is modulo 2, that means even values. Modulo 4, that means 4 multiples of 4. Modulo 8, multiples of 8. That means plus 8 incrementing. Each value will be incremented with plus 8. and 16. Each value will be incremented plus 16, then 32, then 64, then 128. H address is inside 0 to 1000. Okay. These are our, according to your specification, you can generate any of the values. Okay. Mostly specification of AHB is same like this only, right? Mostly we will generate in the same way. But you can try different values also if you have any idea. Okay. Next, H address increment. Okay, how the address will be incremented. See, 001 0113. Okay, 0101. Okay, 1357 1357 odd values for each H address of I. If I is not equal to 0, H address of I is equal to H. These all are just observe and I try to understand according to the specification. All the constraints are taken. Okay. Once you put time and once you understand line to line, then only you will get that point what happening. And 4-bit wrap, so burst is equal to 010 means what? 4-bit wrap. H size is equal to 000. 000 means how much? 8-bit. And 010 means wrap 4 burst, H burst. So H burst, H size. If H address of I is greater than 0, then H address I minus 1 to 2 down to 0 plus 1 is equal to 3-bit 100. H address of I. H size is equal to 001. Then what are the H address values? H size is equal to 010. Then what are the values? 16-bit wrap based on H size values. Just go through that and check. Okay, you will understand clearly just how we have written the constraints. Clear till here? Any doubts? Hello. Any
Yeah,
doubts?
it's clear.
Next sequence.
Here in the transaction, these sort function, busy location, these are the in the post randomize.
Sort is nothing but it's queue method or array method. Just we need to sort the data like order
Okay.
order of data. Okay, ascending order or descending order like that sort. Okay, next sequencer. Sequencer, just a small block. Here there is a virtual sequencer. Okay, virtual sequencer. When do we use? What is the use of virtual sequencer?
When we have the many sequences, it will act as a handle of the all the sequences.
Okay. So whenever we are writing multiple number of sequences, the physical sequences of multiple sequences, we will connect to the virtual sequence or sequencer. Through the virtual sequencer, we can access all the physical sequences. So this is how we will connect here. Just have a look. And sequence item completed, next nothing but a transaction. So sequence. In sequence, we write actual test cases. So see here sequence. AHP single trans sequence, it is one test case. Extending from UVM sequence, it's a parameterized sequence. So AHP transaction. UVM object utils creating the object, and AHP transaction creating the REQ copy to transactions, and this temporary address and constructor, and main task body. In the sequence, we use main task body. Through the task body only, we initiate the transfer to the driver. Okay, in sequence, in a task body, what we need to write? What are the steps we need to write? First of all, we need to create the transaction class, and we need to do the randomization and send to the DUT. All these things we need to write. Without writing all these 4 to 5 steps, there is a one single step we can write. What is that? What is that? Without writing declaration and this randomization and sending to the mailbox, all these things we don't need to write. There is a one statement, one macro. What is that? Vinita, what is that?
One macro. UVM.
UVM do
UVM
macro.
do. UVM do.
If we want to write the inline constraint, UVM do with macro. Have you not remembered?
Yeah, so forgot that.
Okay. So here, just created the transaction instance and start item. So if you see the transaction flow between the sequencer and driver, we need to follow this flow exactly. Okay. Start item of request or randomization with the inline constraint, and finish item, get next item. Get next item is written in the driver. Okay. So here finish item, and and the request copy. This transaction data copying into the request copy, HR write data, start item of request for request copy for second transaction, finish item for second transaction. Okay, without writing all these steps, we can write a single step like UVM do macro or do with macro. That's what I do. Okay. So that is what first test case, and second test case, AHP increment sequence, which is extending from UVM sequence. AHP transaction object utils constraint HBurst inside 1357. 1357 HBurst. Okay, HBurst 1357. What are the values? Only increment values. Go to transaction and check. 1357. Okay, yes. Only increment. Wrap means 246. 246 only. Okay. So this test is related to increment. So H burst is 1357. Next, constructor, task body. In the task body, just need to do the randomization start item of request or randomize method, finish next item, and copying to the request copy. And third test is related to the wrap. Wrap means what is the burst value here? Constraint, okay, 26468. Constraint is uncommented, is commented. You can write same. Burst is nothing but 2468. Okay, burst transfer, wrap transfers. Next, task body, sequence item, request dot randomize. H burst is equal to I. Write is equal to 1. Busy state is greater than 0. H burst is equal to 100. Okay, 100 wrap 8. Okay. Size is not equal to 010. Size is not equal to 010. Okay, 32-bit size.
So
Okay,
this test
remaining.
is basically for the increment only. That's why we have, I mean, right now commented the for the burst and all like that.
What increment?
Like in the constraint we have done, right? That H trans is equals to 1357 only. So that means for the increment type only, like that it is, that's
Yes.
this sequence is for
Yes. H
to test
burst
that.
1357 means increment 4, increment 8, increment
Yeah,
16,
yeah.
like. Mm.
Yeah, so
It refers
in
to this data.
constraints, we are checking for that only for these tests. Is it like
Yes.
that?
Nothing but it's a test case, right? One test is
Yeah.
checking for increment, all 4 scenarios for increment. Another test is for wrap, all 4 scenarios of wrap. Another one is a single transfer. First we have written this is main single transfer. This
Yeah, that's what I meant. That's what
AHB
like,
single trans sequence, no burst. Hmm. Hello,
yeah.
your voice breaking.
Hello?
Yeah.
Yeah, that's what my question was. Like that only. Like right now we are checking for this one and we have commented for other constraints.
We just commented here. You can check, you can uncomment and check.
Yeah, check. Yeah, okay, okay.
Next,
Yeah, like
in
here.
main task body, so here temporary and just creating the task body in that calling the super dot body um, and virtual sequences. Here, how many sequences are there? One is a single trans sequence and the wrap sequence, and the one is a increment sequence. 3 test cases, 3 sequences are there. Okay. So all these 3 sequences, physical sequences, we need to connect in the virtual sequence. Through the virtual sequence only, we need to access all those. Okay. So how we are creating the virtual sequence? See here class uh, virtual all sequence extending from UVM sequence hash AHB transaction and creating the object utils here and for single transaction just instances for these 3 sequences take the instances and declare the P sequencer. In virtual sequences, we use the P sequencer, right? What is the difference between P sequencer and M sequencer? Difference between P sequencer and M sequencer. No idea. M sequencers are used to access within a sequence. Okay. P sequencers means both the P sequencer and M sequencers are used to access the sequences within the sequence. But M sequencer mostly it's a manual kind of thing. Like it's a data member of the class. The typecast will be manual. We need to call. But P sequencer means mostly recommended is a P sequencer. We mostly prefer the P sequencer compared to the M sequencer. Nothing but it's a user defined handle will be there. Okay, so if you see here, declare pre-sequencer, virtual sequencer, it's a user defined handle so that you can explicitly declare and typecast your own custom sequence. Okay. and it will give you the access to the different variables functions in your own sequencer. Mostly user defined kind of thing only. We use P sequencer. It's the best practice. Okay. So here created the P sequencer and virtual sequencer and declared the temporary address bit and function new and task body, creating the wrap sequence equal to AHB wrap sequence type ID create. What is the use of create method in system in UVM? Because in system verilog we use the new method, right? Why do we use the create method in UVM? Create. No idea? Just check with that. So single sequence dot start, you know, to call the to initiate the transaction flow between sequencer and the driver, we use the start method only within the body task body. So here start method, single sequence dot start of P sequencer wrap sequence dot start increment sequence dot start. Okay, using start method. If you didn't remember if you didn't remember UVM, better take this week time, revise. Okay, revise all the concepts because every concept is important, and then you start working with this protocol. Okay, after sequencer completed, just a sequencer is a routing purpose. We use routing between the sequence and driver. And coming to the driver is same as system verilog only. Just go through that. Not much more difference. Just we create the class extending from the UVM, creating the virtual interface and transaction. And driver is a component, right? That's why we use the component util and just create the function. And build phase, just in build phase, we just declare the config db. What is meant by config db? Get method and put method, get method and set method. Config database. No idea? You need to revise the concepts. Otherwise, if I want to explain all, it takes a lot of time. I can explain, that's not a problem. But once you have some clarity, I can explain some extent. Okay, so just revise. And task virtual run phase. Build phase means we just declare or we just we don't create, we create. Okay, build phase means we need to create but we can't connect. In the connect phase we need to connect the blocks, all generated driver monitor sequence scoreboard. Okay, in the build phase we just create. And run phase, in the run phase we just we need to do entire transaction from we just need to do the reset and then transaction data to DUT. That's all done in the run phase. So this is entire run phase. Just check. And monitor is just opposite to driver. Just getting the DUT data to transaction. Just check here. And top level environment, you know already how to connect the environment, discussed already in system verilog. Scoreboard, just here scoreboard scoreboard component utils analysis port is used here. Why? Because in this particular example we have coverage and scoreboard, right? What is the difference between TLM port and analysis port? Can anyone explain? What is the difference between TLM port and analysis port? TNM port means 1 to 1. Analysis port means 1 to many. We can connect by using the, we don't use get methods in analysis. We just use write method to write the data. Have you not remembered the concepts? So here, just check comparison logic in scoreboard. Just go through that. I will share you the codes today, everyone. Whatever leftover blocks are there, just work on that. Coverage related and AHP pipeline driver and rundown to file for coverage. And here there is a assertion also, and top level environment and test test.sv top level and testbench.sv. These things you already know. Just if you observe once, you will get clarity. In the next session, if you want, I can give one more overview of this AHP protocol. First of all, you need to revise the UVM concepts. If you don't revise the UVM concept, it is difficult to understand line to line. Okay. Any doubts? Any doubts? Nitin, Shweta, Vinita, Karthik, Tamanna. So next session will be on Thursday. We can discuss on Thursday, okay? Thursday or Wednesday. We'll let you know.
Ma'am,
Okay.
Wednesday is sorry, Tuesday is also our class, no?
Hmm?
Tuesday. On Tuesday
Tuesday.
also.
Mhm. Yeah, Tuesday you have a session, UVM.
Okay.
We are going to start UVM.
Okay.
Okay.
Yeah.
Okay, then that's it. Just have a look of entire code. In
And
the
ma'am,
next session, look
and
this and start AHP to APB. Yeah,
and ma'am, when our code session of SB happen?
this week or on Saturday, next Saturday.
Okay. Code practice.
Yes.
Okay. And ma'am, do we, sir, or are you give more example on system Verilog code writing is
System
a whole
Verilog
page?
already assignments are there, right?
Okay. Okay,
Those
so
are
can we discuss on that assignment on that on Saturday?
okay. Yeah.
Oh,
Saturday, just coding questions.
okay.
Yeah. Okay. Any other doubts, Karthik and Nitin? Okay, thank you. Bye.
Thank
Thank
you.
you.